Hi everyone, this is Math Done Right with another math video, and today we're looking at solving rational equations. So a rational equation is an equation where the x appears in the denominator of a fraction, right? Remember the denominator is the bottom of a fraction. So for a quick little example, we've got something like 5 over x equal to 2, right? We see the x is in the bottom there, so that gives us a rational equation. Now, let's remember that a fraction is undefined when the bottom is 0, right? I can't divide a number by 0, and so a fraction is undefined there. And so when we look at rational equations, we have to really be concerned about that because we might get a solution that actually makes our equation undefined. And so we're going to call the domain of an equation to be where the equation is defined. And when we're going through these problems, we're going to get solutions. We're going to have to check the domain, make sure our solution is in the domain for it to be a valid solution. All right, so let's get started with an example. All right, so let's look at 5 over x plus 2 equals 3. So I can see that I have an x plus 2 in the bottom here, so this is a rational equation. Now what I want to do is first multiply both sides by x plus 2. Like so. Now the reason I do that is because, well, now these cancel out with each other and I'm left with 5 equals x plus 2 times 3. Now, just like regular distribution, I'm going to distribute this 3 inside of here, and I'm going to get 5 equals 3x plus 6. I subtract 6 from both sides, and I get negative 1 equals 3x. Divide both sides by 3. I get x is negative 1/3. Okay. X is negative 1/3. Now, since it's a rational equation, I need to make sure that negative 1/3 is in my domain. So what I'm going to do is find the domain of this equation. So the way I'm going to do that is I'm going to find what makes the denominator equal to 0. And everything that isn't that number is the domain of the function. So I'm going to look at this x plus 2 and set it equal to 0. And solve for x. Okay, well that gives me that x is negative 2. So what that means, if I plug in a negative 2 into here, it makes my denominator equal to 0. So the domain is x not equal to negative 2. It's everything besides negative 2. Now there's a few ways we can write this. So we can write this as the set of x such that x does not equal negative 2. Or as an interval notation, I can say this is negative infinity to negative 2 union negative 2 to infinity. Now I have to check my solution and see if it's in the domain. Well, my solution is x equals negative 1/3, and this is indeed in the domain of my equation, right? The only value that wouldn't work here is negative 2. So x equals negative 1/3 is my answer, and I checked it. It's in the domain. Okay, now let's look at another one. Example 2. Let's look at 3x over x plus 5 equals negative 2 over x plus 5 plus 1. Now this is a rational equation because I have x plus 5 in the denominator, so I want to get rid of it, and the way I'm going to do that is I'm going to multiply both sides of the equation by x plus 5. So I'll end up getting something that looks like this. X plus 5 times 3x over x plus 5 equals x plus 5 times the entire right-hand side. I'm going to do this in 2 steps. Now, oh, this is in parentheses also. Very important to keep the parentheses there. Now I must take this x plus 5 and distribute it in here. to both terms. So when I do that, first I'm going to kind of save myself a step. I have an x plus 5 times 3x on the top divided by x plus 5. So both of these cancel each other out. So I'm left with 3x on the left-hand side equal to negative 2 times x plus 5 over x plus 5 plus, now I have 1 times x plus 5. Okay, now I need to simplify the right-hand side. Well, I have an x plus 5 over x plus 5, and this is being multiplied, so it's okay to do that cancellation here. So those cancel out. And now I have to distribute this 1 inside of here. And when I do that, I get, let's go up here, I get 3x equals negative 2 plus x plus 5. Now, if you watched my other video solving linear equations, this is just a linear equation now. So I'm going to subtract x from both sides and get 2x equals negative 2 plus 5 gives me a positive 3. Divide both sides by 2. I get x equals 3 over 2. Now, before I circle my answer, I'm going to make sure that it's in the domain of the function. So now I'm going to find the domain. So I'm going to do the same thing I did in the previous problem. I'm going to set the denominator equal to 0 and solve for x. So to do that, I subtract 5 from both sides. I get x equals negative 5. Now that means that when I plug in negative 5 to the bottom, I get 0. Remember, I can't divide by 0 because we're dealing with a fraction here. So that means the domain is x does not equal negative 5. The domain is everything but negative 5. All right, and now I look at my answer. My answer was 3 over 2. Well, that's in the domain of my function, so we're good to go. And that's the solution to this rational equation. Great, 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 great. Alrighty, let's look at another example. This is going to be example number 3. Let's look at 3x plus 1 over x plus 5 equal to 6x minus 2 over 2x plus 4. Now, this is an example of where I can just cross multiply. So what that means is I'm going to take this denominator, multiply it by that numerator, and take this denominator, multiply it by this numerator. So that's going to give me 3x plus 1 times 2x plus 4 equal to 6x minus 2 times x plus 5. Now I have to expand or FOIL both of these terms out over here. So I have to take 3x, multiply it by 2x, 3x, multiply it by 4, and then I have to do 1 times 2x and 1 times 4. Alright, so that's going to give me 3x times 2x is 6x. Whoops, let's go back to black. That's going to give me a 6x squared. 3x times 4 gives me a plus 12x. 1 times 2x is plus 2x. 1 times 4 gives me 4. That's the left-hand side. The right-hand side, I have the same thing going on. So I have 6x times x gives me 6x squared. 6x times 5 is plus 30x. Negative 2 times x is minus 2x. Negative 2 times 5 is minus 10. Now, if you've been keeping up with these videos, I haven't shown you how to solve if I have an x squared term, but they're going to cancel each other out. So I'm going to subtract 6x squared, subtract 6x squared, these cancel, and what am I left with? I'm left with a 12x plus 2x plus 4 equals 30x minus 2x minus 10. I'm going to combine like terms. So that's going to give me a 14x plus 4 equals 28x minus 10. And now I'm going to subtract 14x. And that gives me 4 equals 14x minus 10. Add 10 to both sides. And I get 14 equals 14x. So that gives me that x equals 1 if I divide both sides by 14. Okay, so now I want to check the domain of this function, or this equation, sorry. So I'm going to set both of these denominators equal to 0, because now I have two different denominators, two possibilities where the equation would be undefined. So I have the first term equal to 0, gives me that x equals negative 5, and then I have 2x plus 4 equal to 0. That gives me that 2x equals negative 4, which gives me x equals negative 2. Now I look at my answer, I got x equals 1. Okay, so this gives me that x does not equal negative 5 and negative 2 is the domain down here. Now look at my answer, I got x equals 1. Well, that's not negative 5 or negative 2, so this is indeed my solution to this equation. Alright, so now there's one more example. Example 4. Alright, let's look at 5 over x minus 2 equal to 3 over x minus 1 plus 5 over x minus 2 times x minus 1. Now, just like we've been doing before with these other problems, I want to get rid of these x's in the bottom. And if these were just regular numbers here, the way I would do that is I multiply by the LCD, the least common denominator. And that's exactly what I'm going to do here. I'm going to find the LCD. Now, a way to do that with numbers is just to take the product of whatever is on the bottom, right? If I have something over 7 plus something over 3, the LCD is 21. And how did I get that? I just multiply the 7 and 3 together. So I have an x minus 2 and an x minus 1. If I take their product, oh look, I get this denominator over here. And so I can say the LCD of this equation is x minus 2 times x minus 1. And just like any other problem with fractions, I'm going to multiply both sides of the equation by the LCD to get rid of these fractions. Fractions are ugly, everybody hates them, let's get rid of them and solve. Okay, so I multiply the left hand side first. So I've got x minus 2 times x minus 1 times 5 over x minus 2 equal to, now the LCD multiplied by the entire right hand side. So I have x minus 2 times x minus 1 times the entire right hand side. Okay, now I have to distribute here like I would normally. Both of these terms times the first one, and then both of these times the second one. Now, at the same time, before I distribute, first I'm going to try to simplify this. Well, I've got an x minus 2 on the top here. Let's extend this fraction line all the way. I've got an x minus 2 on top. Everything's being multiplied, and I got x minus 2 in the bottom. So it's okay to slash these out. I can cancel there. And I'm left with a 5 times x minus 1. Alright, now the right hand side I've got to distribute. So I've got an x minus 2 times x minus 1 times 3 over x minus 1. And I've also got an x minus 2 times x minus 1 times 5 over the same thing on the bottom. X minus 2 times x minus 1. Now, just like I did in this first step, I'm going to cancel the x minus 1's out in that term. And now in this term, I can cancel out both of these guys. What am I left with? I have a 5 times x minus 1 equals x minus 2 times 3 plus 5. Now I have to distribute this 5 into here and this 3 into here and just solve for x, just like it was just a regular linear equation. So when I distribute, I get a 5x minus 5 equals 3x minus 6 plus 5. Now I'm going to subtract 3x from both sides and get 2x minus 5 equals minus 6 plus 5 gives me a negative 1. I'm going to add 5 to both sides and I get a 2x equals 4, which gives me that x equals 2. Great. So that is potentially my solution, but now I have to check the domain. So let's check the domain. Now, it suffices to just check to see what makes the LCD equal to 0 because it's the product of everything on the bottom. It's the smallest thing that is a product of everything on the bottom. So I can just do that. So let's set that equal to 0. Well, that gives me two things. That gives me x minus 2 is 0 and x minus 1 is 0. So the first one gives me that x equals 2, and the second one gives me that x equals 1. So that means that if I plug in a 2 to the bottom, I get 0, which is bad. If I plug in a 1 to the bottom, I get a 0. That's also bad. So my domain is x does not equal 2 and 1. Now I go back to my solution, my potential solution. I don't know if this is a solution yet. It may not be a solution. It may not be in my domain. I got x equals 2, but look at my domain. It's x does not equal 2. I can't plug in 2 to this function or this equation and get a result. Because if I plug in a 2 here, I'm going to be dividing by 0, and that's bad. So I go over here. I'm going to slash this guy out, and I'm going to say no solution. 3 exclamation points. Alright guys, well, that's my video on solving rational equations. If you have any questions that you want to ask me, I can do a video on, just leave it in the comment section. Make sure to like and subscribe, share with your friends, teachers, professors, whoever you want. Thanks guys, bye.